Welcome to Energy Talks, a regular podcast series with expert discussions on power system testing topics. My name is Scott Williams from the podcast team at Omicron, and I will be your host. Partial discharge measurement and analysis are together considered to be a highly effective, non-destructive diagnostic method for assessing the condition of electrical insulation. Most PD measurements have been typically performed under AC voltage to detect potential failure-causing insulation defects. However, the increasing number of DC power grids is intensifying the need for measuring PD under DC voltage as well. With me in this episode to discuss the differences between AC and DC partial discharge testing and what you should consider when performing these tests are Bogdan Gorgan and Ulrika Brunetsky. They are both members of the PD services team at Omicron, as well as instructors who conduct training courses and webinars for Omicron Academy about PD measurement and analysis. Bogdan and Ulrika, a warm welcome to Energy Talks.
Hi, Scott. I'm happy to be here.
Hi, Scott. Thank you for the invitation. Happy to be here.
Super. Thank you again for being here for this discussion, both of you. Bogdan, let me start with you. What is AC partial discharge testing?
Well, AC partial discharge testing is a PD test done at alternating voltage at AC. What that means is that the applied voltage during the PD test can be sinusoidal and can be close to operating frequency, 50 Hertz, or even higher, up to 400 Hertz, for example.
Okay, so ACPD testing has been mainly performed up to now. Why is this so?
Yeah, it has been performed for many, many years, and that's because the high voltage equipment is mainly stressed in operation by alternating voltages, 50 or 60 Hertz. I think this is the reason why the most important test voltages and AC voltages, and these voltages are applied as withstand tests, lifetime tests, dielectric, and PD tests in general.
Okay. How and when is ACPD testing performed, and on what types of equipment?
Yeah, good question. The ACPD testing is typically performed during, let's say, the development of the new insulation. It can be as type routine test, commissioning test, so on site, even when the asset is in operation as a periodic check, before or after maintenance works, as temporary or even continuous monitoring. So we can say that it can be performed in all stages of the asset life cycle.
Okay, and what types of assets are we talking about?
It can be power transformers, rotating machines, cables, GIS, steel, even special kind of insulation.
Okay, thank you, Bogdan. Ulrika, could you tell me what DC partial discharge testing is and how it differs from AC partial discharge testing?
Well, DC partial discharge testing is actually almost the same as ACPD testing. The only difference is that now we don't have any alternating voltages, but we have direct voltages. So usually we have one voltage level which doesn't change, or maybe we have polarity reversal tests, so it changes a couple of times. And so we're making PD tests while the voltage isn't changing. So this means that also one of the most important tools that we know from AC PD testing, which is this phase-related patterns, these PRPD patterns, that are not applicable for DC testing, and because we don't have any voltage phases that we can relate any PD to. And also some of the other tools we are used to using, like looking for the inception and extinction voltages, for instance. It's very hard. I won't say it's impossible, but it's much harder as the single impulses, they appear more seldomly, actually. So there's a longer time between those single impulses. So we need to look for different tools for the interpretation of the DC PD measurement. We could look, for instance, to the individual pulses shape, to the impulse shape, or we could look to the frequency spectrum of this impulse. Or we can build relation diagrams between the apparent charge of different PD pulses, or the time or the voltage difference when they appeared, or also the time difference between those two different pulses. So we can think of a lot of new diagrams we can build for the interpretation, but our old diagrams that we are used to and love with ACPD testing, they are not available any longer.
Interesting. Okay. So what has led to the need for DCPD testing?
Well, our energy grid is changing, and also we all know that we are changing how we produce our energy. So most of the time it's no longer like a power plant that's near a city center or inside a city or whatever, but we have much more renewable energy. And those renewable energy, it's mostly created at remote distances. For instance, if you think about an offshore wind park, or like a tidal power plant or something like that. So they're usually located far away from the people that need the energy, like from the cities, or also from the industry. And thus we need to transport the energy over a longer distance. And it's easier is not the correct term, but we have less losses of energy if we do this with DC voltage.
Interesting.
So if you want to transport energy for a long distance, we have less losses if you use DC, and thus we have much more like DC transport need, let's say. So we have a lot more assets that see DC voltage, and of course we need to test all these, yes, because we also have increasing voltage levels, and of course the safety is very important. So we need to test all these different assets.
Okay. How and when is DCPD testing performed, and what types of equipment?
The equipment is actually very similar to what we're used to doing AC testing. So the equipment for AC testing is defined in the IEC 6270, and the equipment for DC testing is basically the same. So we need a test object, of course, and we need a coupling capacitor and a measuring impedance, and of course a voltage source. There's only one big difference, and now we cannot use the coupling capacitor any longer for the voltage measurement itself, but we need separate resistive voltage divider for the voltage measurement itself.
Okay.
But apart from that, it's very, very similar. And we have some standards that are defining like the DC testing, for instance, for HVDC converter transformers, or bushings for DC applications, or also for HVDC shunt reactors. There are IEC and IEEE standards available, but what we don't have at the moment is similar standards for DC GIS or DC cables. And there are SIGWA working groups, for instance, that were formed that are dealing with this topic, and they're discussing and thinking about, what kind of standards would be useful. But at the moment, we don't have it. So at the moment, some of it are actually tested under AC voltage because it's better than not testing at all.
Yeah, interesting. What challenges does that present?
To my knowledge, what's really happening in the insulation, as we talked about, PD testing is about insulation testing, and what's really going on in the insulation on an atomic level, like when we're talking about electrons, it's following different mechanisms than if we do testing under AC voltages. And if we have different mechanisms, also like how faults develop, let's say, it can be different. So it's not 100%, we cannot 100% be sure that if we do AC testing, like the same results apply one-on-one if we then stress this asset with DC voltage. So we're not 100% sure that we can take the results of AC testing and apply it to a DC equipment.
Bogdan, as you know, the biggest challenges of PD testing in the field is noise. How is this resolved with ACPD testing, for example, with Omicron's MPD800?
That's right. So when we are testing in the field, there is a lot of noise. And actually, if I can tell a little story, when I have started to perform PD tests some years ago, I really thought that it would be more straightforward. And when I go there on site and performing the measurement, I will look at the results, and it was easy to interpret because there were only impulses coming from the asset or none. And the reality was that there are a lot of PD pulses. And so the engineer has to start to identify if these impulses are from the asset or coming from the surroundings, because this is what is happening on site, especially. And then, therefore, you start to appreciate this system like the MPD800 that has a lot of tools that the engineer can use in order to deal with this problem. So if I can start to mention some of them, but first of all, because I talk about AC testing, we do use the existence of the diagram, the so-called PRPD, phase resolved partial discharge diagram, what Ulrike mentioned earlier. And so this is a perfect start to identify different problems and noise. So, but what we have with the MPD800 is it's a fully digital system that has a freely adaptable digital filter that can be moved in an area where the noise is the lowest while being sensitive enough to PD impulses coming from the asset itself. Different gating methods are available. So we can use the software for gating, or we can use the second channel that is available with the 800 for the same purpose, so to gate the signals that are unwanted. The knowledge and recognized separation methods that Omicron has, and everyone knows them from the 600, the so-called three-part diagram and the three-frequency diagram, or three-frec, they are also available with the 800, but the usability was very much improved within the software. So I guess I would like to mention the last thing, that the software is at different level, and the user will be more comfortable when we start to use the new MPD suite, because it is user-friendly and it's really easy to use in the end.
Okay, thank you. Ulrike, DCPD testing is performed differently than ACPD testing, as you mentioned before. It also faces challenges with noise separation, which are different than by ACPD testing. How is this handled, for example, with the MPD800?
Yes, Scott, as I mentioned before, we have much less impulses as a start, like much less PD impulses than compared with AC testing, which means that it's even more important with DC measurement that we really know if this is an impulse from our asset, from our insulation, or if it's an external impulse. And also, as we don't have those PRPD patterns, but mostly, as defined in the standards, we're simply counting pulses. It's also another reason why it's very important to distinguish between the pulses. And but unfortunately, it's also a little bit harder. So we have actually, mostly we can apply the same methods that we can also apply for AC testing. For instance, we do have the gating functionality, because the physics behind it is actually the same. So we can use the gating to separate external and internal impulses, like external being from outside the asset and internal being from inside the insulation of the asset. We have this three-frequency measurement method, which is a very good tool in this surrounding where we don't have like a three-phase measurement or something, but this three-frequency measurement still gives us the possibility to distinguish PD from different locations.
Okay.
Also, we can use a balanced bridge setup, which is very useful in this situation as well.
Mm-hmm. Okay, for differential PD measurements.
Yes, exactly. Also, sometimes it is quite useful, and we can use sometimes an AC trigger to build this PRPD diagram that we know from the ACPD measurement. Because if we have an external impulse that is triggered from the surrounding grid, which is connected to an AC voltage, it will perform our usual known patterns, whereas something that is from the device under test under DC voltage, it will not perform or form a pattern at all. It's something like a little trick, yes, to distinguish if it's from triggered by AC or by DC voltage, which also gives you information. And the MPD800 gives us this creativity and gives us the ability actually to do those little tricks, because we can just simply trigger on different voltages.
I understand that with the latest version of the MPD suite software, the MPD800 offers special tools to make DCPD testing easier. What are these tools?
Well, one of these tools actually is the gain setting, so we can easily adapt and choose the gain value. Because as we say, we have seldom impulses. We don't want to lose any single impulse, which we sometimes do when we have a gain change while we're registering an impulse. So we can quite easily adapt this and have it fixed, which is very useful for the measurement itself. And then we have two special types of diagrams where we can show our DCPD measurement, and they follow what is written in the standards, where we have defined tests. So usually these are PD counting diagrams, which are counting PD over a certain time window. Also, what we can do is we can export the recorded DC as a CSV file to put it into to allow for further evaluation. And we can do this actually during the measurement, but we can also, like with all the MPD, like we know it with the MPD600 as well as the 800, we can do a recording, and we can also do this export from the recording afterwards. And something that is also nice that I talked about before, that we can sometimes look at the impulse shape of the PD. We now have the possibility to trigger our scope, our PD scope that we have in there, to catch the shape of the impulse, and we can also use this for analysis.
Interesting. Okay, great. So that certainly makes the challenges better to deal with.
Hopefully.
And I would say, does it offer users the capability to take that insecurity with DCPD testing away that they may have, because you had mentioned that there are no set procedures in place?
Yes, for the moment, at least, it helps, especially as long as we sometimes we don't have the set procedures. It helps to have a lot of possibilities what we can do. And and there's some of these possibilities are really nice and really a step forward compared to the MPD600, for instance.
Great. Well, Rika, thank you. Bogdan, are there situations when the user will want to perform AC and DC PD testing at the same time? And for which applications does this apply, and what are the advantages of this?
I think for the equipment that is supposed to work in a DC network, a PD test under DC voltage makes sense, of course. But having the problem that we don't have established or standardized methodologies of how to test and how to interpret the results we just discussed under DC tests, the user prefers also to do the test at AC voltage. And so I think by comparing the results between the two tests, we can understand the particular defects that exist or might exist for that specific asset and how they behave under the two different stresses. So one can learn from this parallel test, let's say. And maybe I can give you an example. For the high voltage DC GIS, if we have metallic particles inside and that are moving inside the GIS, then this process is really different when you excite the asset with AC voltage than when you do it with the DC voltage. So this is important for us to compare and to learn.
Thanks, Bogdan. Now I have a few questions for both of you. How do you see the future, for example, for ACPD testing?
I think my answer would be that yes, definitely. I mean, the PD testing and the AC will remain important in the future due to its discussed advantages. Yeah, so the existence of the phase angle, and this is the most important tool to identify anything, and using the procedures and the standards that already exist for measurement and interpretation. And of course, the assets are continuously built and they need to be tested. And we need to know the quality of the insulation. So this has to be evaluated, and this will happen in the future as well. Yeah.
Okay. Thank you. Ulrika, what is your opinion about the future of DCPD testing?
Yes, as I already mentioned before, there's still a lot to be learned about DCPD testing, especially about the interpretation of the results. But currently, it is researched at a lot of different research institutes, and new analysis tools are proposed. And of course, we're following these researchers and these developments very closely, and assessing also the tools that are proposed. And in my opinion, all those techniques that will become more and more precise, and it will be much easier to use them and to do the interpretation in the future. And at the same time, the experience with DCPD testing will also grow, and we know more and more about the DCPD also under operation, if we think about DCPD monitoring, for instance. And I firmly believe that PD testing will always be a very important part of assessing the health of the asset, as it's one of the most important tools to assess the health of the insulation. And thus also DCPD testing will stay very important.
Okay, great. Thank you. Here's my next question. Bogdan, why would you encourage power system engineers to perform PD testing in general?
Yeah, Scott, I think this is a very good question. And I'm discussing this a lot of times with different people. Look, there are multiple methods, and especially non-invasive or non-destructive methods that can be used to assess the quality of different insulation systems. And these can measure dissipation factor. We can look at the capacitance. We can look at the insulation resistance. We can do a frequency domain spectroscopy. We can do a depolarization current method, or we can measure dissolved gas analysis. All of these methods tell us what is the quality of the insulation. But from my experience, measuring PD offers, I think, two important advantages. It offers the best results that due to the fact that defects can be detected at their beginning, so at the incipient state. So in other words, you are very sensitive and you can detect the critical defects that are localized, whereas with the other methods, you can't. And of course, the other advantage would be that, yes, the evolution can be monitored. So this is a method that can be looked at when the asset is in operation. And having this or doing this allows the engineers to react in time before a failure happens. Yeah, I think these are the main advantages that the PD testing has. And there are other advantages, but I will say that these are the most important ones.
Definitely most convincing for conducting or performing PD testing.
Yeah, if I may add something, Scott.
Yes, please.
The fact that the partial discharge testing is in general more complex to perform and to analyze, I think that this can be solved with the right training and a little experience.
Ulrika, what is your opinion?
I would elaborate a little bit on what Bogdan already said. I'm meaning that actually what's harming the insulation in the first place is actually the PD itself. Yes, so there's some PD happening in the insulation, and this is causing the destruction or the degradation of the insulation. And this is what's leading maybe to a breakdown. And most of the other methods that Bogdan mentioned, they don't measure the phenomenon, the source, but they measure like the outcome a little bit, or they measure the residual, the side effects. And in my opinion, it makes absolutely sense to try to catch the source of the developing problem. And that way, in my opinion, it's really the first step actually to look at the PD if we can, of course. Yes, some of the other methods Bogdan mentioned there may be easier to interpret or whatever, but if we can, it's always the best, in my opinion, to look for the source, the PD. And well, everybody's developing, especially if we talk to one another and if we share our experiences. And thus I firmly believe that we will get better with time. So we will find better interpretation methods. We will improve our software as we already done with the MPD suite and the MPD800. So we will have better and better measurements, measurement systems on the market, and we have better software that helps us and gives us even better tools, which makes the interpretation in the end easier and makes it easier for the user with time to interpret the PD measurement, which is, as we also mentioned, sometimes complex. We need to say this, but yes, I really hope, or no, I really believe in development there, and that it will be, that we always have a positive development and it will get better and better.
Bogdan, where can our listeners get more information about PD testing at Omicron?
The quickest way is to look at our website, omicronenergy.com, and over there on the products or application sections, first of all, you find a lot of material, so like papers or brochures, etc. But also on the same website, you can find what you mentioned, the trainings that we offer. Both of us, we are part of Omicron Academy, and we do offer these trainings. And before Corona, we used to offer the customer to come here at our premises, but also we could go there as well on site and perform together the practical part, let's say. But right now, we do offer online live sessions. So the customer can join us in a live session, which can be done online. And I would say that at a similar level that we used to do face-to-face. Of course, when Corona is started to minimize anyway, but it will be the effect will be lower in the future, so we can restart our on-site and here at our premises the trainings.
In-person trainings.
Yeah. In-person training. Also, we offer webinars, and this information can be found on our website. Additionally, I have to say that we are very active in participating at different conferences, different workshops. We publish our work in different magazines like IEEE, SIGRE, and who is interested, they can find the work presented there as well.
Okay, great. And Ulrika, let me ask you, do you necessarily have to be an Omicron customer to attend these webinars or courses?
No, you don't have to. So we don't take your entrance ticket at the beginning of the training. No, of course we do the training for everybody that is interested, especially the webinars. They are a very, very nice way to have very easy way to dive into this topic of PD measurement and see if it's useful for you.
Mm-hmm.
And also for the longer and more intensive trainings on PD, we do beginner trainings, let's say, for people that haven't done PD testing before.
Mm-hmm.
And it doesn't really matter if you own an Omicron device or if you don't, because the methodology of how we do perform PD testing, that is really universal, as it's described in an IEC standard, and we follow that standard. So it's really applicable for different measurement devices, of course. Participants can learn from one another because we have participants that are all facing similar problems, sometimes with different companies, but most of the time the problems are very similar. And so we can have exchange there and discuss about different problems or how you solve them. And I think also this personal exchange, that is very, very nice. And that's what I like a lot about the trainings.
Very good. Well, thank you for that. Ulrika and Bogdan, thank you both very much for joining me for this episode of Energy Talks.
Scott, thank you so much for inviting us and for the interesting questions you put to us. It's been a pleasure.
Also, Scott, thank you from my side.
And a big thank you to our audience for listening to this episode of Energy Talks. We always welcome your questions and feedback. Simply send us an email to podcast@omicronenergy.com. Omicron has several years of experience in power system testing, including, of course, partial discharge measurement and analysis, and it offers you the matching solution for your application. For more information about our testing solutions, as well as online courses and webinars offered by Omicron Academy, please visit our website at omicronenergy.com. Please join us to listen to the next episode of Energy Talks. Goodbye for now, everyone.